Sorry. Okay, equal x minus 3 over x minus 6. Wow, this is complicated, right? So what should I do first? Well, factorization. Factorization any expression in the bottom. In the bottom we have x plus 4 is prime, x minus 6 is prime, but this is trinomial. What kind? Regular. And the factorization, I suppose, is 4 and 3, no? Because 4 times 3 is 12, 4 plus 3 is 7, plus. Okay, super. After that, find the LCD. And remember, LCD is the collection, any factor that we have in our problem without repetition, no? You take x plus 4 one time. You take x plus 3 one time. And you take x minus 6 one time. Because we have only one, no? Entonces, the restriction associated with that problem is a bad solution, it's a extraneous solutions. Is negative 4, is negative 3, and positive 6. No equal. Now multiplication. Let's do it fast, because I don't want to copy again 3 times. This is too long LCD. And when you are doing the multiplication LCD by the first one, it's obvious that this and this cancel out. And stay this x, que es this x, times x plus 3, x minus 6. Wow. Plus 8, x plus 28. However, let me see, using another color, x plus 4 is cancelled again, and x plus 3 is cancelled again. And so stay only x minus 6. In the right hand side, we have x minus 3. And cancel out who? X minus 6. And stay. The other part is not green, and is x plus 4. Wow, x plus 3. This is too long. I never put in the test something like that. Okay, I want to do this. The second is horrible. Okay, so now multiplication this. We have 3. In this case 2, and we have 3. Entonces you, to multiplication 3, well, in this case it's easy, or relatively easy. You take 2, associate the property, the first and the second maybe, a multiplication like that. Entonces x squared plus 3x times x minus 6. Instead to continue to the right, I continue down. Manipulate this, and you FOIL again. This is x cubic, cubic equation. This look like weird. Minus 6x squared plus 3x squared minus 18x. This is cubic, square. Okay. Now we continue. Yes. You combine like that as x cubic minus 3x squared minus 18. Okay. Okay. This is easy. This is only the one FOIL. These two binomial. Is plus 8x squared minus 48x plus 28x minus, I put in my calculator, 28 times 6. 28 times 6, 168. 168 again. 168. And you combine later here and here. So it says plus, copy down, 8x squared minus 20. We go 48 and 28 together. Subtraction is 20, no? minus 168. So this is the left hand side. The right hand side, wow, too complicated. Is you multiply this and this is x squared. This is 4x. This is minus 3x. And this is plus 12. One more time, we combine here is x squared plus x plus 12. Multiplication now by x plus 3. Plus 3. Entonces, x cubed. This is 3x squared. I did the first one. The second is x squared plus 3x. And finally 12x plus 36. Wow. So we combine like term here, que is 4, so x cubed plus 4x squared. This is 15 plus 36. And the right hand side. And the left hand side we have a cubed. So we combine like term here and here. F5. 5x squared, a minus 3, no? Plus. And this is negative 38x minus 168 equals. This is my equation. Wow. Well, unfortunately, I can see that this and this say goodbye. You cancel out this. It's the same guy in opposite sign, the right and left. You can cancel out. Now this looks like quadratic equation. So I move everything to the left, maybe. 5x squared minus 38x minus 168 minus 4x squared minus 15x minus 36 equal to 0. I move this guy to the left. And we combine later. This and this is 1x squared. I like that because that means it's a regular trinomial. 38 and 15 together is 38 plus 15. 15 is 53. 53. Entonces, pero 53 negative, minus 53. 53x was a combination 38 and 15. No? 13 carry that 1. 53. Good. Pero minus. And 169? 68. Sorry. Plus 36. It's 204. Wow, I don't know. The minus 204, no? 204. 204 was a combination 168 and 36. 14 carry that 1. This is 10 carry that 1 to 204 equal to 0. And do the factorization. This is really stupid. Okay. Okay, that is the reason in the chapter 5 we study in detail another way to do that. However, in my calculator I can do that. Now, let me try. See, it's possible. See. No, it's not possible. It's not possible the factorization. Or maybe I am doing something wrong, but it's too long. Or no solution. Because it's impossible to do this equation. Okay? No solution. No solution. And the other is horrible. So now my recommendation, don't do that. Don't do that. And the test, of course, I don't put a stupid problem like that, no? Let's move on to another topic. case different. I don't cover so far, but it's easy. Okay. Look, it's that part. Okay. Okay. This is variation. It's a technical name, variation. So we have two kinds of variation. Variation, we have directly proportionally. So when you're talking about directly proportional, or inversely proportional, suppose inversely, so directly proportional is when you have, for example, one variable, I don't know, y, is directly proportional with another variable, x, when you multiply by one constant. K represent constant. A constant is one number that I need to find sometime. So now, this is directly proportional. Directly proportional. And inversely proportionally, very inversely proportional is, for example, see y is k again, pero divided by x. That directly proportional is multiplication. Inversely proportional is division. Okay, this is basically the two ideas. Directly proportional, inversely proportional. Okay, let's do a problem number one. Number one say the variable y vary directly as x. Okay, so you know que y vary directly with the x. We are doing number one. You don't know who is k, but one condition is given. If y is 20, when x is 80. Entonces, the question say find the constant. So you need to find the k value. Entonces, y is 20, k, I have no idea, x is 80. Divided by 80 both sides, because I want to solve for k. It's obvious that it's 1 over 4. Cancel out the 0, divided by 2 is 1, divided by 2 is 4, k is 1 over 4, 1/4. This is the constant of proportion. 1 over 4 is the answer. So this is important and easy. Okay. Suppose now the second example. Do you follow me? In the second example, is similar. We have the y is directly proportional with x. It's again using the same variable. Y is directly number 2 proportional to the x. When y equal 15, so y is equal 15 when x is 3. Okay, it's doing. So you replace 15 is equal to k multiplication by 3. Divided by 3 both sides. 15 divided by 3 is 5. K is 5. The answer of the constant of variation is 5 in this case. Everyone follow me? It's easy, eh? Let's move on to the 3 and 4, case about inversely proportional. Okay. In this case, it's the same. You need to find the constant. But the formula for the inversely proportional is y, for example, is the constant divided by x. Entonces now, y is equal to 0.5 when X is 3.5. Bueno, it's a decimal, but don't worry for the decimal because you use the calculator, no? Entonces, 0.5 replace y by 0.5, the constant here, and X is 3.8. Okay, you apply like a cross multiplication, maybe, no? You multiply like that, bam, bam, and multiply like that, and you put in the calculator 0.5 times 3.8. 1.9. That's 0.5 multiplication. 3.8 is 1.9. And 1 times k, this is the k value for this variation. 1.9 expressed in decimal. That was number 3. And now number 4. Number 4 is z. Very inversely as t. Constant t. C is 22.3 when t is 72. Okay. 2.3 is z. The constant is the thing I'm looking for, and t is 72. Again, cross multiplication, like that. K alone is the multiplication 2.3 times 72. Wow, 165.6. 165.6 is the answer. Guys, do you understand the idea? Direct proportional, inverse proportion, and the test no. In my test no, but in Alex maybe you see problem like that. Okay. And the next page we see another word problems involve directly proportionally or inversely proportionally. Okay. Any question? No? All right, let me see. Opinion. Do you see? Do you understand? Wow, look at that. We have full class now. Alejandro Aguilar, Ramsés, Noel, Dalida, I receive your test. I don't grade, but I receive, okay? Kevin? No, don't worry. Everything gonna be okay. Sherman, Collins, Angelica, Edward, Kendry, David, and Juan Gomez, and Alex Manuel. Okay.
I'm here.
Yeah, I know. Okay, let's move on to the next page. Que es the continuation. That part, I suppose. Let me see. Okay. Boom. Let me see. Yes. It's that part. It's that part. Okay. It's a word problem. The word problem can involve somehow variation, direct proportion. The number of patients of the Dr. Wong can see vary directly as the time it takes her to see them. If she can see 11 patients, but let me declare a variable. Patient P. Vary directly as the time. Time is T. This is my variable. The independent is T, depending is C. And the connection.
We lost your whiteboard.
Say again?
We lost your whiteboard.
Ow, sorry. Okay. Why?
Does anybody else see it?
No, so you don't see it because I don't share that. Now, David?
Yeah?
Do you see whiteboard?
No.
No? And the rest of the students, yes or no? No? Okay. Sometimes happen. Okay, I need to, yes, I see. Kevin, I see. Maybe we have time delayed. Let me see now. Yes, you see, David.
No, I don't see anything. I see a blank screen. I hear you, but I don't see you.
Wow. Okay, let me try again. So one possibility is, let me see. Sometimes I stop sharing, not sharing anything.
Oh, now I can see you.
This is the idea. After that, I want to share the whiteboard again. And maybe the connection is restored. Now, David?
Nice. No. And I'm on a computer. I'm not on a laptop. And, I'm sitting in my apartment like I'm traveling.
I understand. Okay, it's important to get good computer or laptop when you take class online, right?
Absolutely.
Okay, so let me read. The problem number 5 say, the number of the patients of the Dr. Wong can see very directly as the time. Okay, the time it takes her to see them. Okay, so how you translate these two equations? No, patient is P. I put capital P because I consider it's important. And the word very directly means que es equal constant, I have no idea, multiplication by the time, que is the time. If she can see 11, so this is the condition that can help me to find is she can see 11 patients, so P is equal to 11, in 3 hours. So add T equal 3 hours. How long is time? So this is the first condition. So this is the condition that is given. This condition is given to find the constant, similar to the previous problem. Okay, entonces they asked me about another condition. Okay, is for example, P equals 66 patients. Entonces I need to find this time. Okay, I have no idea. Question mark. Entonces we have two steps. No? You plugging in the condition that's given, que es 11 here, is equally constant, multiplication by 3. Entonces 11 over 3 is my constant. Okay, I feel no, I need to find the time. Entonces I set out the equation again, but I know que K is 11 over 3. Multiplication by T. Okay, but in the condition 2, I know that the number of patients is 66. So if you replace 66 is equal 11 over 3 times T. You need to solve for T. Well, the easy way for solve for T is multiplication both sides by a reciprocal, que es 3 over 11. 3 over 11. When you multiply any number times its reciprocal, the answer is 1. So it's just T. And here we can put in the calculator if you want. Or it's easier because you can cancel out 11 is 1 and 6. And multiplication 6 times 3, 18. 18 what? What is the unit of that? How long? And my problem say okay, the time is measured in hours. So 3 hours. Remember, this is hours. Therefore, 66 patients, Dr. Wong can see in 18 hours. Make sense? Make sense? Make sense? This is a little bit more complicated because we have two steps. Step 1, you compute the constant. And step 2, you set out one more time the equation when the constant is given. You have in your hand here the constant, and you set out the condition, the second condition is given. So, do you follow me? It's clear or confusing?
Professor, I'm a little lost.
Pero you see the board. You see the board or no?
No, I don't see a board.
Well, entonces, okay. Entonces it's a little bit hard to explain si you don't see the board.
What's the
Yeah,
mathematical?
yeah, at the beginning, David, you see the board at the beginning of the lecture.
Yes, sir.
Wow, entonces I don't understand. Okay, entonces my recommendation is go out, log out, and log in again. Come on, quick. Try. Come on, quickly.
Okay.
Dale, go ahead. And let me know. Okay, let's move on to number 6, sorry. Okay, is again similar. Okay, we have two conditions. One condition is given. You need to find the second condition. Okay, now. Okay, let me see. The speed of the vehicle vary inversely as the time it travel and the fixed distance. Wow. Okay, entonces the speed. Okay, speed. So you put it the variable like that. Speed vary inversely. Inversely, I know que es a constant divided by t, que es the time. Okay, let me read again. The speed of the vehicle vary inversely as the time it travels, then the fixed distance. Okay. If the vehicle travel, okay, just give me condition 1. Condition 1. And the condition 1, I have in my hand a fixed distance at 20 miles per hour. So 20 miles per hour. What is that? This is a speed. This is a speed for the condition 1. In 60 minutes. Okay, this is the time for the condition 1. 60 minutes.
Oh, thank you, Professor. I see the board now.
Oh, super. Sometimes happen, David. Okay, entonces now, what's the confusing part, at least in that problem? Okay, the speed is given in mile per hours, and the time is given in minutes. So I need to convert to the same unit. So to satisfy this equation, the supposition is que the unit matching perfectly. Entonces no unit is hour, because I know que 60 minutes is 1 hour, so t equal 1 hour, es equivalent, no? And now, entonces the speed is 20, the constant, I have no idea, and the time is 1, not 60. Cross multiplication one more time is 20. The constant is 20. Okay, entonces now I set out the equation again by the second condition, speed is equal, but I replace, I know this is 20 over time. Okay, how fast is speed? So I need to know in the condition 2, what is the new speed? Question mark. Speed, I have no idea. How fast must be traveled, cover the same distance at 25 minutes, and the time is 25 minutes. Entonces, I need to convert 25 minutes to hours. Entonces, divided by 60, no? 25 divided by 60 is, okay. You convert this to hours, you divide 25 over 60. Because I know que 60 minutes is 1 hour. And you put in a calculator, it's 5 over 12. You put in decimal fraction, either way. Then I need to find the speed. The speed is equal to 20 divided by 5 over 12. Okay, remember the division of the fraction, you copy 20, you suppose que 20 is 20, it's a whole number, so it's 20 over 1, and you flip it at 12 over 5. Flip it the denominator. You put in a calculator, no, much better simplification, divided by 5, 1, divided by 5, 4, and 4 times 12 is 48. Let me check it out, 48 what? What is the unit of that? We are finding speed, mile per hour. That's the answer. The answer here is 48 miles per hour. Okay. This is no big deal. Let's just apply the formula. And we have two possibilities, no? Directly proportionally and inversely proportional. That's it. In my test, no, you don't see. In Alex, maybe, no? Okay. Let's erase the board. Let's move on to the next. The next is the classical spawning problem. Okay. Now let me see. Oh yes, this page important. Boom. Okay, it's doing. Okay. Number one, say 27 raised to the 1/3. Oh, fraction exponent. What means fraction exponent? It means in radical notation cubic root, because this 3 is this 3 and it's power 1 que es invisible. Yeah, I know that this is 3. Wow, easy. The answer is 3 here. So we have in the second, this is the first one, number 1. Number 2 is negative 16 raised to the 1/4. And this is very, very confusing. And number 3 is very, very similar. Parenthesis negative 16 raised to the 1/4. Okay, what is the difference between this and this? Okay, the same stupid thing, that this negative is behave like a -1. So you copy, just copy, and that's it. And you convert fraction exponent to radical, get 4√16. And 4√16 is 2. This is 2, because 2 times 2 times 2 times 2, 4 times is 16. And you put -2, because this -2, you just copy to the last part. This is -2. And the answer is real, yes, equal -2. However, in that case, it's different, because the 4 root -16. Yeah, I need to know that when you have negative number, negative quantity inside the root, que the index is even, we have no real solution. Always. Only if the index of the root is odd number, we have real solution. Pero si es 4, si es 2, si es 6, no real solution. Entonces no solution. Be careful. Inside the radical negative, no solution. When the index is even. Okay? When the index is odd, no. Number 4 is negative 64 raised to the 2/3. In this case, yes, we have solution, because it's, look, it's cubic root. Wait. It's a cubic root. So this 3 is this 3. Cubic root negative 64. Everything raised to the second power. So the denominator of the fraction is the index of the root, and numerator is the power, the extra power that we have. In this case, yes, we have solution, because negative number inside the root, the index is odd number. Yes, we have real solution. In this case, -4, because -4 times -4 times -4 3 times is -64. 4 times 4 is 16, 16 times 4 is 64. And 3 negative is negative positive, pero positive times negative is negative, entonces es negative. And it's a square. So I did that part. So the answer for this part is -4. And now square. Square is 16. Okay? 16 positive, regardless que es negative, because you know que negative number when you square become positive. The answer is 16. Any question, guy? Everyone follow me? Sure?
Yes.
Okay, super. Okay. Okay, let's move on to the variable part. If I say x to the 3/4 times x to the 2/3. Okay, now I don't see any arithmetic symbol, but I suppose default is time, period. Okay, And you know the rule of the exponent. When it's multiplication, it's addition. Basically, you add 3 over 4 plus 2/3. And this is my new exponent. I know, okay, to add into fraction with different denominator, you find the LCD, que es 12. 12 divided by 4 is 3 times 3 is 9. Plus 12 divided by 4 by 12 divided by 3 is 4, sorry. And 4 times 2 is 8. This is 17. 17 over 2. This is equivalent to say x 17 over 2. Let me read. They want, they want you express it like exponent. Entonces x, the exponent is 17 over 2. Like that. That was number 5. Number 6 is again, but in number 6 we have a negative exponent. Three-quarter. Okay. Or you convert negative exponent to positive, or multiplication. That's it. It's negative 1 over 4 plus 3 over 4. In this case, the same denominator. Nice. I love it that. It's negative 1 plus 3. Que es 2 over 4. And 2 over 4, the lowest term, is 1/2. And the answer is then x raised to the 1/2. Everyone follow me? Easy, eh? Okay. Number 7. Well, number 7 is a little bit more complicated because we have several. We have, let me see, x to the 1 over 4 times x to the negative 1/3 division x to the 2/3. Okay, my recommendation is convert any negative exponent to positive. This stays the same because it's positive. This stays the same because it's positive. However, I change this to positive 1/3 in the bottom. So you change from the top to the bottom and change the sign. So everything is positive. In my opinion, it's much better, more understandable. And now let's do in either order, division or multiplication. I prefer multiplication first. So you put x to the 1 over 4 and you multiply the two guys that we have in the bottom, que es 2/3 plus 1/3 is 3/3, is 1, just 1x. 2/3 plus 1/3, LCD, bueno, es the same, es 2 plus 1, que es 3, and 3 over 3 is 1, and 1 is invisible exponent. Not necessary to write here. Finally, division, and division is subtraction. Okay, let's do it. And subtraction is, let me erase at least that part. Okay, entonces 1 over 4 minus 1, que es that one. Es 1 over 4 minus 4 over 4, ¿no? Es minus 3 over 4. And the answer is x raised to the negative 3 over 4, pero never, you leave it like that, never the final answer is expressed using negative exponent. No. Okay, therefore, you convert to positive. How? You put in the bottom, like a 3 over 4. Okay, the answer of this is 1 over x raised to the 3 over 4. That's one of number 7, no? Number 7 problem. Okay, number 7. Okay, number 8. Number 8 is, wow, is for parentheses. Parentheses. 4x to the 6th power raised to the -1/2. Wow, negative exponent, I don't like. So you convert negative exponent to positive. How? Flip it. Reciprocal. This 1/4 x to the 6th power raised to the 1/2 positive. So you convert negative exponent to positive exponent, you switching to the bottom, no? And now me automatically is positive. And leave it like that. No. I want to convert to radical. This is a square root for x to the 6th power. Alright, so you separate square root 4. In my mind, I separate like that. This is square root 4 times square root x to the 6th power. Square root 4 is 2. And this is x to the 3rd power. Final answer. Okay, so it's 1/2 x cubed. Okay, super. This is the easy part. This is look like a example of the middle school. Okay, look. Again, number 9 is involved 3 guys. Okay, but no, the same variable. Okay, so you combine, but you combine only when you have the same variable. X to the 1/8 times y raised to the 2/3 divided by x to the 1/4. And the only possibility is that the rule of the exponent is valid when the base is the same. See, the base is different. Why no? No. So you combine. This is division. This is 1/8 minus 1/4. LCD is obvious. It's 8. 1 minus 2 is -1/8. Wow. So far we have, when you are doing that division, okay, I did. The answer was x to the minus 1/8 times y minus 2/3. And leave it like that. Of course, no. Never we can express the final answer using negative exponent. Then you switch into the positive exponent, put in the bottom. Because this, I suppose, okay, we have 1 here. So they flip it. 1 x to the positive 1/8 times y to the positive 2/3. And it's a more clear answer. Okay? Well, we have no space to write here. Okay, so 1/x, yeah, 1/8 times y 2/3. Okay, let's do the last one. The last one is -6. -6 x to the -3/4. Wow. But you see, you need to be aware for any combination, positive or negative. So my recommendation, you can manipulate the negative. But no, I don't like. Well, this is the coefficients, it stays the same. But the exponent, no. This negative, I put in the top like a positive. And this negative, I put in the bottom like a positive. I feel much better. Ready to start. Division and subtraction. 1/4 minus 3/4. This is 4. 1 minus 3 is -2. Over 4, reducing lowest term, -1/2. And so far, we have -6 x to the -1/2. Final answer, no. Of course, no. Never express the final answer using negative exponent. It's -6, the coefficient it's illegal to be negative because coefficient, but exponent, no. X to the positive 1/2 in the bottom. Final answer. -6 over x to the 1/2. Okay. Okay, this was a problem to practice a little bit the property of the exponent. Remember, addition, multiplication is addition. Division and subtraction, power of the power is multiplication. And negative exponent, you convert to positive exponent. You put in the bottom and the top, depending on in the opposite side. Well, I can erase everything. I finished that page. Everyone follow me, guys? That was easy, eh? Was easy, right? Answer me. Jasmine, was easy, right? Yes, okay, super. Okay, no problem.
Yes, it makes sense.
Yeah. Okay, let's erase everything. Let's move on to the next page. The next page, let me see. Review 4. Specific what page is the next? Let me see. I did that. Okay, we almost finished. Okay, that page. Boom. Boom. Radical now. Okay, let's do it. Number 1, say square root 4x cubic. Well, you can separate like a square root 4 times square root x cubic. Square root 4 is 2. And cubic, we can do something. Why? Because cubic, I know, look at that. Cubic is like x times x times x, no? 3x. Entonces, we can select one couple of x. And this couple of x go outside like only one x. Entonces, now we have x outside and stay inside 1x, que es this. And this is my answer. My answer is 2x radical x. Anyone follow me? So number 1. Number 2 is cubic root. Will be careful. 54. 54x cubic. So you try to break it down 54 in primary factorization. 54 is divisible by 2 because ending in 4 is even number. And 54 divided by 2 is 27. 27 is divisible by 3, is 9, is 3 and 3. And remember, we are working with the cubic root, so we need selection 3 by 3. Not like that, it was 2 by 2. But this triplet of 3 go outside like 1, 3. So we have so far 3 outside and stay inside 1, 2. I did the numerical part. And what about the variable part? Well, it's x cubic. It's exactly x cubic is, I did here, is x times x times x. It's exactly the same amount of 3 we need to go outside like a 1x. And this x, I put it here. Boom, final answer. The answer is 3x cubic root 2. Everyone follow me? Yes or no? It's super easy. The radical is super easy. Guy, I told you. The hardest is number 3, and you pass. Now there is a super easy, and chapter 5 is super easy. I guarantee you. Okay, let's do number 3. Number 3 is, again, we come back to square root 20, x to the 3rd power, y to the 5th power, no? Fi, yeah, a 5th power. Simplify this expression. Okay, 20 is 210 to 5. I can find a couple of 2. That means 1, 2 go outside. Then the numerical part, we have 2 and 5 inside. This is the numerical part. I left some space here because the variable x and y, I don't know exactly what happened. So x cubic is x times x times x. A couple of x outside 1x. And it take another x, que is this inside. And the y fifth power is 1, 2, 3, 4, and 5. We have a couple, we have another couple, go outside like a 1y, go outside like another y, and y squared outside, and stay 1y, que is this, inside. And this is the answer. The answer is 2x, y squared outside, radical 5, xy. There are many ways to do this. So, also, another way is not necessary because this is too long. In this case, 3 and 5. But suppose get 30. This is more complicated doing that way, no? So you try to find while it's raining heavy here. The even number close to 3, que es x to the second power times x. And the square root this is x. And here similar, it's y4 and y, the even close. And the square root this is y7. Wow. It's too heavy raining here in my home. Do you hear the rain? The rain? Do you hear?
That's the rain?
Yeah,
Wow.
It's a rain. It's a rain.
I thought somebody was like driving and making noise.
Wow, too heavy. Yeah, but it's okay. It's no too long time, I suppose. According to the weather channel. The weather channel, I see. Let me see.
Well, it's sunny over here where I am.
Yes. No, it's only one cloud. Slow, pero es heavy. Okay. Let's continue. Don't worry for this. I speak a little bit loudly. Okay, and you see the image in the whiteboard. Okay, look. Number 4 is cubic root. Negative 27 x cubed. Oh, it's easy. Remember, when the index is odd, yes, we have real solution. It's -3. Because cubic root negative 27 is -3, and cubic root x cubed is just x. And it's the answer. Number 4. Number 5 is division. Be careful with the division and rationalization. Well, not always.
Hey, Professor, I believe number 4 was 27x to the 8th power.
Oh, yes, you're right. Taka, taka, taka. Yes, you're right. It's 8 power. So this is wrong. Okay, let me erase the last part. This is 8 power. 8 power. This is not 3. This is 8. Okay, this is -3 again. But this is okay. 8 to the 8 power. You need 3 close to 3. So the multiple of 3 close to 8. Down. To the 6th power times x to the 2nd power, no? Or you prefer 1, 4, 5, 6, 7, and 8. Let me count. 1, 2, 3, 4. 1, 2, 3, 4. And you select 3 by 3 because it's cubic root. 3 by 3. 3 by 3. This represents 1x outside. This represents another x outside. And x together, x squared. And stay x squared outside. So the answer is x squared cubic root x squared. So it's x squared cubic root x squared. Another point of view is 6 divided by 3 is 2. and this stay inside the cubic root. One of the numerical part I did before is minus 3. Okay? Okay? Either way, use break it down 8 and 6 and 2. Why 6? Because the multiple of 3. What is the multiple of 3? 3, 6, 9. But down. Down what? Down 8. No 9. Because you put 9 to say you introduce negative exponent. Negative exponent is no good. Much better. Thank you, David. Thank you, David.
My pleasure.
Anytime. Okay, now let's move on to number 5. Number 5 is square root. Number 5. 12x to the third power. You check and see I make a mistake. 3x. Okay. Well, there are many possibilities. You separate into radical. But no. In this case, I do not recommend. Why no? Because in this case, when you divide, you simplify. 12 divided by 3 is 4. And x cubed divided by x is x squared. Wow, easy. And the square root 4 is 2, and the square root x squared is x. Done. Final answer. 2x. Okay. Because there are no rules. Sometimes it's very convenient. Do the division first. If when you are doing the division inside the radical, the number is not nice, it's not perfect square, this is much better separate into radical like that. But in this case, no. In this case, more complicated in that way. Okay? In this case, much better division first and after simplification. Okay, let's move on to number, this is 2x is the answer. Okay, now, number 6 is 2 radical. 2 radical 27. Radical. Okay, break it down. 27 and 75. 27 is 39, 33. And 1 cup of 3 represent 1 3 outside. And this 3 times 2 together is 6 radical 3. And this 3 is this 3. Okay? 75, one of the 75 divisible by 3. Remember the rule to determine if one number without division is divisible by 3. You adding 7 plus 5, 12. And 12 is a number that belongs to the 3 table multiplication. No? Now it's divisible by 3 when you divide by 3. So I discover a couple of 5, go outside like 1 5, and this 5 multiplied by another 5 that we have here is 25. 25 radical 3, because this 3 is this 3. Now they are like term, and you add it. 25 plus 6 is 31. 31 radical 3. Okay, the answer. 31 radical 3 is the answer. So the radical is super easy, in my opinion. No? I respect the opinion. It's a big, easy topic in any algebra courses. Okay. Moving on to number 7. Number 7 is 5. Cubic root 16 minus 18. Cubic root 2. We break it down 16. X divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. And we are working with the cubic root. Therefore, use selection 3 by 3. These 3 of 2 represent 1, 2 outside. And these 2 multiplied by 5. Multiply as a factor. Let's take 10 cubic root of 2. Minus 18 cubic root of 2. In this case, we cannot do anything because it's prime. This is prime level. Now they are like term. Combine 10 minus 18 is minus 8. The answer is minus 8 cubic root of 2. Okay. Do you understand, guys? We need. O sea, this is the class online is the solution. But definitely, when the pandemic is over, when the COVID-19 is over, we need to take class in one building, que is called college or university. No, this is completely isolated and silent, no problem. I am teaching another class that is raining too heavy, but I don't hear almost anything. However, here it's different because it's different environments. It's a home, no, it's no college. Okay, let's do it. Let's do it. Number 8 is 10. 10 square root 40, easy. I like square root minus 5 square root plus 3 square root 90. Okay, you take the number inside and break it down. Factorization, factorization, factorization. 220, 210, 25. Couple, couple, because it's a square root. Represent 1, 2, and this 2 times 10 is 20. 20 what? Square root, and the number to stay without couple is 2 and 5 together, get 10. Not necessarily put separately. No, it's completely wrong. Not wrong, but it's stupid. Okay, 50 divided by 2 is 25. And 25, 5 and 5. I discover a couple 5, go outside like a 1, 5, and 5 times another 5 is 25. So minus 25. Radical 2, no? Sí, radical 2. Radical 2. Radical 2. Que es this 2. And 90 divided by 2 is 45. 45 divisible by 3 is 15. And 15 is 3 and 5. We have a couple of 3. Go outside like a 1, 3. And 3 times 3 is 9. Plus 9. Radical 2 and 5 10. Oh, so in this case, it's only possible combine lighter this and this because contain the same radical, que es radical 10. So 29 radical 10 minus 25 radical 2, and this is impossible combine with that. So only is possible in addition or subtraction combine when you have the same radical. Different radical, no. 29 radical 2 minus 25 radical 2. Radical 10, sorry. This is not 2, this is 10. Okay. I see in the weather channel it's only one cloud. Maybe it's complicated after. Okay, this is x radical 20x plus, we are doing number 10, 4 square root 45 x cubed, no? Well, it's okay. This is 210, this is 25. A couple 5, a couple 2, go outside like a 1, 2, 2 times x is 2x, radical 5, okay, it's that 5. 45 I did before, no? It's 3, 15, 35. It's a prime factorization. A couple 3, and 3 times 4 is 12. 12 what? 12 radical 5, and this 5 stay here. But what about x? X cubed, remember, is x times x times x. We have a couple of x outside here, and stay 1x inside. So I discovered again that they are lighter. And you added 14. 14x radical. Radical. Oh, I forgot this x. I just copy here. 5x. Yeah, I forgot. I forgot this x. Okay, this x stay. I can do simplification because there's only one. The answer is 14x radical 5x. And we have time to finish the review. Okay, I'm doing well, I'm doing too fast. This is a review, no? The review is fast. This is supposed to be you, no? Okay. Oh. Okay. Number 10 say 12 radical 50 minus 3 radical 2. Well, 2 is prime. I suppose that we can know simplification more this radical, but this yes. Divided by 2, 25, 5, 5. A couple 5 represent 1 5 outside. This 5 outside multiplied by 12 is 60. 60 radical 2. Okay, this 2 is this. Minus 3 radical 2. 60 minus F57 radical 2. That's 57.
Esther, the rain must be affecting your eyes because I believe it's multiplication, not subtraction.
No, 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 no. Ah, yes. Yes, it's not subtraction, it's multiplication. You always say my life. Hey, it's multiplication. Don't say this is bullshit. This is nothing. It's
I don't know
multiplication.
about anybody else.
Uh-huh. Okay. So basically, David realized que es 12 radical 50 time, no minus 3 radical 2. Okay. Entonces, now you have to remember what is the rule. The rule is multiplication, this and this, and this and that. Okay, there's 12 times 3, 36. And radical what? 50 times 2 is 100. What is square root 110? Then the answer is 30 times 10 is 360. Wow, 360. That was number 10. And number 11 is also multiplication, David. It's 3 cubic root.
Yeah, my mic was off. 11 is multiplication as well.
Okay. 2 cubic root 2x squared. Well, okay. The thing is, okay, you have to respect the rule, and the rule is clear. The rule, you multiply the number outside, because the number outside and the number inside the radical is different category, and we cannot mix it. Illegal, violation. You multiply 3 times 2, 6. Cubic root something. Cubic root of what? Of 4 times 2 is 8 x cubed. Because 1x times x squared is x cubed. This is easy because I know the cubic root a is 2. So cubic root a is 2.
Excuse me, 1 second, Professor. If we're doing 3 cubed times 2 cubed, doesn't it become 6 to the 6th power?
No. Okay. No. Listen to me. Okay. Again, let's do it again. You understand? Okay, I need to multiply the number outside. Okay, 3 and 2, no? Okay, the 3, this small 3 indicate the index of the root. So it's not 3 to the 3rd power. No. So this small 3 is the index of the root. Yes or no?
So that the small 3 is not really part of the number that we're working with.
Exactly.
Got it. Thank you.
Then you multiply 3 and 2, 6. And you put a cubic root of the multiplication 4x times 2x squared. It's 8x cubed. Okay, yeah, I know. Okay, you can separate this like a cubic root 8 times cubic root x cubed. So you copy 6. This is 2 times 2. And this is x times x. That's 12. It's the final answer. Super. Wow. Too much. But we have another page. It's the last, I suppose. Okay, let's move on to this. last page. No, we have two pages. This page. Okay, there you go. The multiplication. Okay, S3 radical 2 parenthesis 12 minus 10 radical 10. Okay, simplify that. When you apply this to the property, you multiply this and this, and you multiply this and this. Remember that 12 is a number without radical. Therefore, you consider it as like a 12 radical 1. No? And when you multiply 36 radical 2 minus 30 radical 20, because 2 times 10 is 20. But 20 we can simplification. 2, 10, 2, 5. This is a couple 2, represent 1, 2 outside. This 2 multiplied by 30 is 60. 36 radical 2 minus 60 radical 5. Is the number que stay here. And we can do something here? Nothing. Because when you have different radical, we cannot do anything. The answer is 36 radical 2 minus 60 radical 5. Okay. The rule is clear. It's clear. You have, for example, I don't know, 10 radical 2 times 2 radical 3. How your multiplication? Multiplication that number 20 and multiplication that number 6. That's it. We cannot mix it. Different category. Okay, let's doing the next. The next is like a, no, es binomial. Entonces 2 radical 7 paréntesis 2 radical 7 minus 5 radical 3 time radical 7 which radical 7 plus 4 radical 3 and you FOIL. Multiplication this and this. Be careful, you need to know by memory que radical any number time itself when they are the same as any. For example, radical 7 times radical 7 is 7. Okay? Radical 3 times radical 3 is 3. You need to know by memory this. It's shortcut. Entonces, 2, this coefficient is 1, invisible. 2 times 1 is 2. And radical 7 times radical 7 is 7. And 2 times 7 together is 14. Okay, this is my first multiplication. Our multiplication is this times this is plus 8 is 2 times 4 is 8, radical 21. Where come from 21? 7 and 3 together. Multiplication. Okay, so plus 8, radical 21. That was our inner, this and this. Is negative 5, radical 21 again. And the last is this and this is minus 20, and radical 3 times radical 3 is 3. Okay, then so far we have 14. We have plus 3, is 8 minus 5, radical 21 minus 60. Multiplication. And now subtraction. 60 minus 14 is 6. Borrowing 1, it becomes 5, 46. Negative 46. Plus 3, radical 21. It's the final answer. Okay, guys. There's a negative 46 plus 3, radical 21. That's the answer. Okay. Okay, let's do one more. Oh, this is easy. because we can apply a shortcut if you want. For example, 14 is a conjugate. Is a conjugate. Is parenthesis radical 5 minus a times radical 5 plus a. So you realize that this is a conjugate. It's like a minus b times a plus b is equal a squared minus b squared. And you apply the formula. A squared is like a radical 5, square 5. Minus a squared is 64. And 64 minus 5 is 59. No, 59. Is, yeah, 64 minus 5. 59, yeah? Negative 59. However, okay, the student can don't like the formulas. Feel much better using FOIL. Okay, it's radical 5 then radical 5 is 5.
Excuse me, Professor, if it's radical 5 times radical 5 is 5, then
Yeah.
8 times 8, 8?
Radical 5 times radical 5 is 5. Yeah, radical 5 times radical 5 is 5. Now, radical 5 times a is plus a radical 5. And negative 8 times
Okay, thank you.
And finally, is minus 64, is the last. And we get, this is always cancel out. This is always happen when it's a conjugate. The radical disappears. Now, we have 5 minus 64 is 59. The answer to this is negative 59. No radical anymore. So this situation, I take advantage in the next page to rationalize. Rationalize means eliminate the radical. And when you have binomial, you multiply by a conjugate. Okay, let me try the last page. The last page is here. Review. Okay, last page. Okay, this is the last page. Okay, rationalize. Suppose example 1 is 5. Pay attention, this is a little bit complicated. Radical 2x. So they want you rationalize the action, the denominator. That means eliminate this radical. So you multiply by radical 2x by radical 2x. In the top we have 5 radical 2x divided by 2x. End the story. Okay, because I know, one more time, radical any number or expression times radical any number or expression when it's the same as any. So I take advantage of this principle to rationalize, que es eliminate the radical. This is my final answer. My final answer is 5 radical 2x divided by 2x. I delete the radical. Number 1. Number 2 is a little bit more complicated because when you have higher root, always is complicated. Look, suppose you have 4 over cubic root 2x squared. To rationalize this, it's different when you have higher 4 root or cubic root something. Because remember, we need, suppose I want to delete that 2 inside the radical. We need, so my smart one is also cubic root, but not 1 to 2. Why 2? Because I know that cubic root 2 times 2 times 2 is 2. Likewise, cubic root x squared times x is x. So we need 2 extra 2 and 1 x, because actually we have only 1 2. We need 2 more 2 in order to complete the trick we need because of the cubic root. And here we have x squared. We have 2x. We need 1 extra x. And this is my smart one. It's a little bit weird. And higher root is complicated. Well, so actually we have in the top we have 4, that 4 stays the same, and this is cubic root of 4x. That's it. In the bottom we have 2x. Because when you put this and this together, is 2x squared times 2 times 2 times x. We have 1, 2, 3, 2 outside the cubic root, 1, 2, and we have 1, 2, 3 x. That's 1x. It's exactly we have here. Okay, do you see it's complicated, eh? And the square root is easy because you complete it with exactly. They are twin brothers. In this case, not twin brother. This is different to this, depending on the factor that you need to complete. Okay. Well, okay. I suppose that in the test I don't put this stupid thing. And rationalize binomial is most important. In the test, yes, I probably can put this. Suppose number 4. 14 over 3 minus radical 5. And the command is the same, rationalize. That you need to eliminate this radical. Now you multiply by conjugate. 3 plus radical 5. Conjugate is exactly the same, but opposite sign. When it's minus, plus. When it's plus, minus. Now multiplication, this and this is 42, no? 42, so 14 times 3, 12, 31, 42, plus 14, radical 5. In the bottom, let's do it FOIL. 3 times 3, 9. 3 times radical 5 is 3 radical 5. Minus radical 5 times 3 is minus 3 radical 5. And minus radical 5 times radical 5 is 5. Minus, of course. Entonces you see it always happen magically. Okay, this and this cancel out. This is the idea for the rationalization. The 42 over 14 radical 5 divided by something. Divided by 4, no? 9 minus 5, 4. We can reduce a little bit. Yes, I suppose you can reduce a little bit. 42 is divisible, no? 42 divided by 4. No. Well, you can reduce a little bit. If you divide it by 2, the entire expression divided by 2 here. And divided by 2, because I saw that the coefficient is even. Entonces 21 plus 7 radical 5 divided by 2. And we can no simplification. Stop. 21 plus 7 radical 5 over 2. That's the only thing we can do. Because now 21 divided by 2 is decimal, no? And 7 divided by 2 is decimal. In algebra, no decimal. I prefer the improper fraction than decimal. Okay, so moving on to the number 5. Okay, we have time, 5 minutes. Okay, look, radical 8 divided by radical 3 plus 1. Again, conjugate. What is the conjugate? Radical 3 minus 1. Radical 3 minus 1. Now multiplication. Radical 24 minus radical 8 divided by 4 is 3. Radical 3 times radical 3 is 3 minus radical 3 plus radical 3 minus 1. This is radical 24 minus radical 8 divided by, this is cancel out, 3 minus 1 is 2. And we can do something, yes, I suppose that yes, we can do something. Okay, because 24, let me check it out. 24 is divisible by 2, que es 12, divisible by 2, que es 6, divisible by 2, is 3. A couple 2. Now we can simplification. Instead of 24, I put 2 radical 6 minus 8 divisible by 2 is 4, divisible by 2 is 2. a couple of 2 again, so we have 2 radical 2 divided by 2. Ooh, and you can split that. So 2 divided by 2 is 1, 2 divided by 2, so 2 radical 6 over 2 minus 2 radical 2 over 2. The final answer, the elegant final answer is radical 6 minus radical 2. Radical 6 minus radical 2. Okay, so you try always, you don't know, but you try to simplify. How you try? Well, you take the number inside the radical, you break it down, and you can see if you have a couple or not. In this case, a couple because it's a square root, no? Si es a cubic root 3 by 3, si es a 4 root 4 by 4, and so on. Okay, let's do in the last one. I promise it's the last one. Okay, is x plus 3 over radical x plus radical 3. Okay, same idea. The conjugate is radical x minus radical 3. Radical x minus radical 3. And you FOIL this. X times radical x is x times radical x. X times minus x radical 3. This and this is plus 3 radical x. And this is minus 3 radical 3. And unfortunately, we cannot combine anything. And the bottom, yes, I suppose yes. Radical x times radical x is x. Radical x times radical 3 is minus radical 3x together. This and this is plus radical 3x. And this and this, radical 3 is minus 3. And this and this is cancelled. In the top, no. In the top, no. In the top, stay the same. What is the final answer then? Is x radical x minus x radical 3 plus 3 radical x minus 3 radical 3 over x minus 3. Okay. We can do something more. I suppose yes. Because we can apply factorization by grouping, maybe, no? Look. Factorization by grouping, look. This and this together. Is there a common factor? Yes. What is the common factor? X. Okay. No. Much better doing another arrangement. Look. Okay, S. Okay, you copy. X, radical x. Plus 3 radical x. No. It's impossible. It's impossible. No, it's impossible. This is the final answer. Okay, the final answer is weird. It's ugly, but it's okay. No, any possibility because you are doing factorization by grouping. Never you get x minus 3. You get x plus 3. Let me see. No. Okay. Entonces, guys, the time is over. I want to recall everyone that the test number 4 that I sent today is due October 4th, so next Monday. Next Monday we start last chapter, it's the chapter 5, and that's it. And we start October 15, the college algebra.